Hello, welcome intermediate algebra students to your first recorded video lesson of the year, 2021 school year. Just wanted to preface this video by saying that I do not expect you to learn just from these videos exclusively. You can always reach out when you're done watching the video, ask me for more videos, one-on-one, small group, whatever you need, I'm here to help. So keep that in mind. With that, I'm going to go through this pretty quickly. Feel free to pause and go back and re-listen to what I'm saying if I ever go a little too fast. So this is a topic, this week should be topics that you've already learned about. Again, if not, that's okay. You can always ask for extra help. I'm more than willing to go back and do it again and again and again with you. And so our topics here are one-step equations for this video. We'll do two-step equations next. And the most important thing you need to know about equation solving is that you're always undoing the operations that are around the variable. The goal is to get the variable alone, and so we kind of peel back the layers to get the variable alone. So it's important that we know what opposite operations are. The operation of adding, the opposite operation of that is subtracting. So if you added something and you wanted to undo that, you would subtract. Opposite of multiplying is dividing. So if you wanted to undo a multiplication, you'd divide. And then finally, we're going to be talking about squared, right? That's like x squared. If we wanted to undo a squared, we would do a square root, which looks like that, and it's spelled square root. All right, so we're going to talk about a couple real life, quote unquote, examples of one-step equations where you would be able to do these equations in your head without an equation, but then also thinking about it as an equation can help introduce you to the idea of one-step equations. So let's talk about Adam the adder. He currently has $1,800 saved up, and the car he wants is $2,500. $1,800, $2,500 is another way to say that. How much money does he need in order to save the car, or how much does he need to save to afford the car? So you can think about this in your head, and you're probably in your head, well, he just needs to find the difference between 2,500 and 1,800. You're right, that's all you have to do, but you just solved an equation, and that equation looks like this. $1,800 plus what amount equals $2,500. All right, and then when we try to solve these, we always draw a line down the middle to stay organized. I'm going to minus 1,800 from both sides because that is the addition that we need to undo in order to get the variable, which is x. These two became 0, canceled out, and then when we subtract, we get $700. So even though you can do these problems, all of them, in your head, it's also really good to go through and think about them as equations as well, to get your brain prepped for equations. So next we have Sierra, the subtractor. She ran out of storage on her iPad, so she decided to delete some videos to clear out space. So she deleted this many videos. Deleted is a subtraction from her total, and she now has 650 remaining. So what's going on here is Sierra had some amount, that's when we use x if we don't know the amount, and she subtracted 240 from it, and she was left with 650. Now again, you could do this in your head without an equation, but the point of this is to introduce you to the idea that really it looks a little confusing at first, but it's all things that we do in everyday life to figure out little math problems. So that would be 890 videos. So here we were trying to get the x alone, and instead of subtracting, we did the opposite, which was adding. All right, next one, Morgan the multiplier. They're getting paid $25 an hour, which is pretty good. At the end of the day, they earned $175. So they want to know how many hours did they work. So 25 multiplied by how many hours gives you $175. And again, there's so many different ways to do this. You could probably just do this in your head. Think about how many quarters are in $1.75. But in algebra, if we want to learn about how this is solved, we don't use the multiplication symbol because mathematicians are lazy and they want to skip it. So that looks like this, but there's actually secret multiplication. And then we show solving this by showing dividing by 25. So show division by using on top and bottom like a fraction. Now the x is free to go, and we just did the division to get 7. 7 hours of work. All right, DeAndre the divider is a sweet grandmother. She gave each of her grandchildren $40, but how much did she total? So the way we think about this, if we were going to use algebra, is that we have the total amount was divided amongst her 12 grandchildren, and each grandchild got $40. So we want to know, how do we solve this? Now this looks a little different. When we are trying to undo division, we actually use multiplication. So it's on the side that we put the opposite operation. Now 40 times 12, that's 480. So grandma gave out almost $500. Pretty great. So we're going to take away the real life situations now, and we're going to do these examples together. So let's do it. We got x plus 8 equals 32. Draw your line down the middle. What's happening to the x is a addition, so we use subtraction to get rid of it. Cross it out. Now the x is alone. We rewrite that x down below, and we know that the answer is 34. Because 32 minus 8. And you put that in your calculator, top to bottom, 32 minus 8. All right, here's another one like the one we saw before. 5 next to the x means multiply. And so when I divide, it looks like a fraction. The x comes down, we get x equals, and this one, you could use a calculator for. So you do 28 divided by 5, which is 5.6. On your quiz that you're going to do this week, it would be written as 28 over 5 though, because we keep it as a fraction. All right, next one, we have division. The x is being divided by 7. And so to get rid of division, we do the opposite operation, which is multiplication. So x equals 21, 3 times 7. Do another one here. X is subtract 10. So the opposite of negative 10 is positive 10. And so that cancels, right? It becomes 0. X is now alone, and we just add top to bottom. So negative 20 plus 10 is negative 10. Wow, we're really getting through these. All right, so now don't be scared. The x is on the right-hand side, but that 12 is still being added to the x, and so we still need to subtract 12 from both sides. That gets rid of the positive 12. The x comes down because it's now alone, and we have 40 minus 12, which is going to be 28. Again, in your calculator, top to bottom, 40 minus 12. All right, last one. From me, before you got to do yours, this is multiplication. The negative 2 is being multiplied by the x, so we need to divide by negative 2 on both sides. In your calculator, you would put in negative 50 divided by negative 2, and it's top to bottom. Negative 50 divided by negative 2, and we get 25 is equal to x. All right, you're gonna pause the video. You're gonna try these examples on your own, and then when you come back, you are going to check your answers with me. All right, so here are your answers. In order to get credit for your notes, though, you need to show the work. And I know that might seem silly for some of these because they're sometimes very simple, but you still need to show the work on how you would get your answer for these questions in order to get credit for the notes, because we're not there with you, we're not seeing you do it, so you could have just copied, right? So go ahead and show your work, make sure you got the right answers. The only one that is a little tricky is this one here. Make sure you're converting your answer to a fraction on your calculator. If you need help with that, go back to week 2 and look through the calculator tutorial slides, and it'll show you how to do that. All right, one more example from me, and then we'll be good. All right, so I kind of jumped a little bit here, so let me Get rid of that. Okay, try again. This is a picture of a square made up of lots of little squares. And so the point of this question is to illustrate when you might use this square root to solve an equation. So if we're looking at the square, it says there's the total of the squares is 196 small squares without counting what is the length of each side. Okay, well, you're probably curious. You'd rather just answer this question by counting instead of having to do an equation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 is the side of the length of the side of the square. So how can we use algebra to do that same thing? We are going to say there's 196 is equal to the sides multiplied by each other. So we don't know what the side is, right? We're pretending we don't know what the side is, so that means we're going to use x. And then you multiply by itself, so it's x squared. So we're going to be doing the square root on both sides, and I'll show you how to do that on your calculator. So go ahead over to your calculator, and you're going to put the square root button in first, and then 196, and then press the good equal button, and you get 14. So that's how you use your square root button on that calculator we did the tutorial for last week. I show that the square and the square root have canceled each other out, and I put my answer as x 14 equals x. Now, some of you who might be more familiar with squares and square roots know that there's sometimes two answers to a square root, a positive and negative. We're just going to look at the positives here right now. So go ahead and pause the video, and then you're going to show your work for these on your own examples, and then come back and check your answers with me. All right, so should be good to go. I hope that this video was helpful. Again, if this is something you haven't seen before, or you don't remember, or it's just really, it's a struggle for you, that's totally fine. This is not the only way that you have to learn. You can set up an appointment with me. I could make another video for you. You could ask me a specific question and I could redo that question more carefully. I just wanted to make this quick video. I hope it went well, and I will see you either Monday, Tuesday, or sorry, either Monday and Thursday or Tuesday and Friday for our synchronous lesson. Bye!